penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi Guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Sirih berlipat, sirih pinang berasal dari Pulau Mutiara. Pemanis kalam, selamat datang. Awal bismillah, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam Malaysia Madani dan selamat datang ke Pusat Tuisyen Online Percuma Akademi Youtuber Malaysia dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Apa khabar semua guru dan anak-anak didik saya dari seluruh Malaysia di mana jua anda berada? Cikgu Hasnitah doakan anda sentiasa berada dalam keadaan sihat walafiat. Baiklah, seperti biasa, insya-Allah pada hari ini kita akan bersama-sama dalam tempoh 1 jam untuk kita pelajari satu lagi topik dalam fizik tingkatan 5 untuk kelas DLP, iaitu tajuk kita pada hari ini standard kandungan yang ketiga untuk bab 2 iaitu 2.3 gas pressure. Jadi bagi memulakan kelas pada pagi ini, ayo kita mulakan dengan bacaan Ummul Kitab Al-Fatihah dan bacaan doa belajar. Bagi yang bukan Muslim, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Jadi insya-Allah mudah-mudahan kelas kita pada pagi ini mendapat rahmat dan berkat pada Allah Subhanahu Wa Taala. Jadi hari ini sudah memasuki 18 Ramadan. Jadi marilah sama-sama kita manfaatkan masa yang ada dengan melakukan segala kebaikan. Mudah-mudahan bulan yang penuh rahmat ini hati kita dididik ataupun terdidik untuk menjadi insan yang lebih baik. Okey, jadi cikgu lupa nak pinkan tadi link untuk bahan yang akan cikgu gunakan pada hari ini. Cikgu kongsikan dahulu tautannya dekat live message, jadi anda bolehlah dapatkan bahan PDF kemudian nanti. Sebentar ya. Okey, cikgu sudah share. Cikgu telah kongsikan link kepada bahan PDF yang akan cikgu gunakan pada hari ini. Jadi anak-anak anda bolehlah klik pada pautan ini dan boleh cetak keluar modul yang cikgu gunakan pada hari ini. Percuma sahaja. Kalau tak sempat cetak sekarang, tak mengapa, ikuti dulu kelas ini. Anda boleh cetak kemudian nanti dan tonton semula video ini untuk dapatkan jawapan sepenuhnya. Okey. So, cikgu kongsikan slide cikgu. Jadi kalau anda telah bersedia untuk mengikuti kelas pada pagi ini, anda boleh duduk dalam keadaan yang paling selesa, bersedia dengan buku teks juga dan mungkin boleh bersedia dengan kertas kosong untuk menjawab soalan yang akan cikgu kemukakan nanti. Anda juga boleh respon Cikgu Hasnitah pada live chat kalau ada apa-apa soalan yang ingin ditanya. Jangan malu, jangan segan, typekan saja di sana. InsyaAllah cikgu akan cuba jawab sebaik yang mungkin. Alright student, if you are ready and good to go, let us begin with our lesson today, 2.3 gas pressure. Kita ada Cia Ying di sana ya. Terima kasih Cia Ying sentiasa bersama cikgu saban minggu. Yang lain juga terima kasih kerana bersama-sama dengan Cikgu Hasnitah untuk kelas pada hari ini. Okay, cikgu perkenalkan dahulu, ini adalah ahli panitia fizik di Akademi Youtuber, guru-guru sukarelawan dari seluruh Malaysia yang telah banyak menerbitkan video PDPC sama ada untuk kelas DLP ataupun bukan DLP. Jadi di mana anda boleh dapatkan video pembelajaran cikgu-cikgu ini? anda boleh muat turun satu aplikasi yang kita panggil sebagai Akademi Youtuber Apps di Android anda. So setakat hari ini kita ada lebih kurang 28,000 video PDPC yang telah dihasilkan oleh guru-guru sukarelawan Akademi Youtuber merangkumi subjek daripada prasekolah hinggalah ke pra-universiti. Jadi harapan kami semoga video-video yang kami hasilkan ini boleh membantu anda sebagai bahan rujukan tambahan selain daripada bahan yang diberi oleh guru anda di sekolah. Jadi cikgu harap semua dapat manfaatkan apps ini sekarang. Kalau belum ada, boleh muat turun di apps anda, Akademi Youtuber Apps. Alright students, so let us begin. Without further ado, let us begin with our topic today. It is 2.3 gas pressure. So in your textbook, this topic is covered from page 56 until page 59. It's a very short topic and not difficult at all. Alright. So to begin, let us take a look at the learning standard we have for 2.3. We have only 2 learning standard. Ada 2 standard pembelajaran sahaja yang anda perlu kuasai. The first one is to determine gas pressure using the instrument called manometer. If you remember, to measure atmospheric pressure, we are using, yes, very good, barometer. And for gas pressure, we are using the instrument which is called manometer. So how does manometer look like? We will take a look at it later. Second is to solve problem in daily life involving gas pressure. Okay, students, to understand gas pressure, take a look at that simulation. Gas simulation. Okay, the red dot represent a gas molecule in a closed container. Titik merah tu mewakili molekul gas pada satu sistem yang tertutup. Okay, so this is to define gas pressure. So from this simulation, how do we define gas pressure? Yes, gas pressure is defined as the collision is due to collision of gas particle and the inner wall of the container. How does gas pressure exist? Yeah, it is due to the collision of the gas particles and the inner wall of the container. So when the gas move in a random direction, it will collide with the inner wall of the container. So it apply a force on that area, so producing pressure. We call it as gas pressure. Okay, very good. Sorry, I reversed it. Okay, next student. Okay, so now the first learning standard. How to determine gas pressure using a manometer. Bagaimana kita nak tentukan tekanan gas menggunakan satu alat yang kita panggil sebagai manometer. Okay, if you look at this diagram, this is the structure of a manometer. It is a U-tube shape that container that fill with liquid. It could be water, it could be oil, or it could be mercury. All right. And students, in this figure, this manometer has 2 ends. Okay, the first end is on the left, second end is at the right. So now it is both exposed to the atmosphere. And you see that the water level in both arm are the same. Okay, sekarang kedua-dua hujung adalah hujung yang terbuka yang didadahkan kepada atmosfera, dan anda lihat paras air pada kedua-dua lengan adalah berada pada paras yang sama. Alright, so in figure A, what happened to both water level when both end of the tube is exposed to the atmospheric pressure? So this is testing your observation. So from this diagram, we observe that yes, both water level are the same. Okay. Okay, then students, second. Okay, now what happen if we connect one end to a gas supply? Apa jadi pula kalau sekarang kita sambungkan satu hujung kepada tangki gas? Tangki gas yang tangki yang membekalkan gas. Sini ada satu valve, so when we open this valve, the gas will flow through this tube and it will act on the surface of this liquid at this end. So from this figure, you can see that yes, now the level in both ends are different. So refer to this question in diagram B. What happened to the water level when one end of the tube is connected to a gas supply? So from your observation, how to write? So we can say From this diagram, we can see when the valve is open, so the high gas pressure will push the water at this level downwards. So this will cause a difference in the water level at both ends. So now you will see when one end is connected to a gas supply, the water level at both ends will be different. And from this diagram, H is the difference between those two levels. All right. Okay, and then the third question. What is the physical quantity represented by the height of water column? So what is represented by H, students? So actually, if you look carefully in both ends, this point A marked as P gas. It shows that gas pressure acting on this point, while at the other end, it is labeled with PATM, showing that atmospheric pressure acting on that end. So H is actually, yes, H is the difference between the pressure difference between the gas pressure and atmospheric pressure. So I repeat, H is the difference between the gas pressure and atmospheric pressure. H itu adalah perbezaan di antara tekanan gas dan tekanan atmosfera. So again, for those who just join us, I have shared the PDF link for this module in the live chat. So now you can get them all for free. Anda boleh cetak keluar secara percuma sahaja. Alright, students. Okay, what do we have next? Okay, now, students, the next question. What is the pressure at A? So as I told you before, at point A, yes, it is the gas pressure. Gas pressure acting on point A. So PA equal to the pressure at point A equal to gas pressure. Tekanan pada titik A sama dengan tekanan gas. Okay, what about the total pressure at B, student? How to determine total pressure at B? Okay, I magnify the diagram for you again. So if you look at point B is at the same level with point A. And student, how many pressure acting on point B? So from our previous discussion into point 2, we understand there are two kind of pressure acting at point B. First is the atmospheric pressure acting on top, and second, pressure due to the liquid in this column, okay, at the depth of H. Yes, so the total pressure or the actual pressure acting at B is the sum of atmospheric pressure and liquid pressure at the column at that height. All right, so the formula is PB equal to PATM plus P water. All right, and now number 6, compare. Okay, compare pressure at B and gas pressure. Give one reason. Why do you say so? Okay, how we compare pressure at B and gas pressure, as I tell you before, since the level is the same, so pressure at both points are the same. Pressure at B equal to the pressure at A, which is equal to the gas pressure. Okay, tekanan pada titik B sama dengan tekanan pada titik A, sama dengan magnitude tekanan gas. Okay. Okay, one last question for this slide. Now write one equation which relate the atmospheric pressure, gas pressure and water pressure. Tuliskan satu persamaan yang menghubungkan tekanan atmosfera, tekanan gas dan juga tekanan air. Okay, macam mana kita hubungkan ketiga-tiga ini daripada gambar raja dan penerangan cikgu tadi? How can we relate all this pressure? Yeah, very good. So it is, yes. Just now for number 6, the reason is because they are at the same level. Okay, so this is the equation for the situation. Gas pressure equal to the sum of atmospheric pressure plus pressure in water. Okay, from this diagram, student, we understand that since the water level at the end, which is connected to the gas tank, is lower compared to the level of water at open end, so we understand gas pressure is greater than atmospheric pressure. So gas pressure is greater than atmospheric pressure, so it gives a higher push to the water, so it will move downwards. Okay, so this is how we understand the situation, and this equation. So are you following me so far? If you can follow me, can you please type 1 in the live chat so I know that you understand what I am discussing here. Okay, kalau anda boleh ikut penerangan cikgu dan faham apa yang kita sedang bincangkan, boleh type 1 pada live chat. Okay, we have Aloy there. Thank you very much, Aloy, for your response, and thank you for joining this lesson. Alright, let us move to the next slide. Okay, students. Okay, now I'm giving you 3 different situations. Okay, we have situation A, situation B, situation C. In each situation, we have a manometer connected to a gas tank, and one end is an open end. Okay, what is the difference between these three situations? The first situation, you can see that the inside the YouTube, we have a water. Okay, so in situation A, the water level at both ends is the same. So what do we understand from this situation? Okay, anyone will try to respond? Siapa nak cuba jawab? Okay, so from here, you look down here, we understand, yeah, gas pressure equal to atmospheric pressure. When the liquid are at the same level, we understand that the gas pressure shown by the green arrow equal to the atmospheric pressure shown by the red arrow. Okay, so we write P gas equal to P ATM. Gas pressure equal to atmospheric pressure. Tekanan gas sama dengan tekanan atmosfera. Okay, what about the second situation? Okay, now the water level in both ends are different. And student, you can see the water level connected to the gas tank is lower. So remember, we understand when the water level is lower, higher pressure acting on that point. So here we understand that the gas pressure is greater than atmospheric pressure. So how to find the total or the gas pressure acting? It is the sum of atmospheric pressure plus the pressure at this column H. Alright. Okay. Then the third situation, now it is opposite to B. Okay. Situation C is opposite to situation B. Now the water level connected to the gas tank is higher compared to the water level exposed to the atmosphere. So here we understand that, yes, atmospheric pressure is greater than gas pressure. So how to determine gas pressure? Now we subtract atmospheric pressure minus the height of column H, or the pressure of liquid in column H. And here is the relation. Okay, here P gas, the first situation, equal to P ATM. Second, P gas greater than P ATM. And third, gas pressure lower than atmospheric pressure. All right, okay. Okay, done with the first learning standard. You know what is gas pressure? It is due to the collision of gas particle with the inner wall of the container. Okay, now students, let us move to the second learning standard. The solve problem in daily life involving gas pressure. Ayuh kita bergerak ke standard pembelajaran yang kedua, macam mana nak selesaikan soalan yang melibatkan tekanan gas. Soalan ni saya ambil daripada contoh daripada buku teks anda. Anda boleh rujuk juga buku teks di sana. Okay, so but I'm sorry, I'm taking the question in English only. Okay, students, for figure 2.19, the figure is here. So we see there is a manometer connected to a gas tank, and the water level at both ends are different. Lower level connected to the gas. So from here again, we understand gas pressure is higher or greater than the atmospheric pressure acting at the open end. And the difference between the water level are at 40 cm. So H is 40 cm. Okay, we have 3 questions there, A, B, and C. Before that, these are the information we are given. Atmospheric pressure 76 centimeter mercury. The density of the liquid using here is mercury 13,600 kilogram per cubic meter, and gravitational acceleration of 9.81 meter per second squared. Alright, okay, first, what is the pressure of the compressed gas in centimeter mercury? Okay, who can answer this? Share your answer in the live chat. So this diagram refer to which situation in our previous slide? Situation A, situation B, or situation C? Okay, we have one answer from one Muhammad there. Thank you very much for your response. 116 centimeter mercury. Okay, what about the rest? What do you say? Do you agree with one Muhammad Zarif? May I know from which school you are from, one Muhammad, and selamat berpuasa to you. Okay. So the answer is yes. So this is the formula. Gas pressure is equal to atmospheric pressure plus the height of column H. Okay, refer to the second situation in our previous. So answer is very good. Thank you. Okay, well done. 116 centimeter mercury. Easy, right? Tak susah pun. Senang saja. Okay, now calculate the gas pressure in Pascal. Okay, Wan Muhammad, macam mana nak tukar 116 centimeter mercury kepada Pascal? How to convert 116 centimeter mercury to Pascal? Okay. The first question asking you to write the gas pressure in centimeter mercury. Second, you have to write the gas pressure in unit Pascal. Okay. I give you a few seconds for you to try convert 116 centimeter mercury into Pascal. Okay. The rest of you also can try. Who's with me right now, you can try your answer, and please don't be hesitate to share your answer in the live chat. If you get it wrong, don't worry, we will correct it for you. Okay. So how to convert this, student? Okay, so this is how we convert. So to calculate the pressure in Pascal, this is the formula we are using, H rho G. Okay, H rho G is the formula for pressure in Pascal. Okay, so now our H will be this reading, but you have to put them in meter. Okay, to apply this formula, H must be in a unit of meter. So 116 centimeter in meter is 1.16. Okay, then multiply with the density of the liquid, 13,600, multiplied by gravitational acceleration, 9.81. So the answer is, 154,762.56 Pascal. Can you please check if my answer is correct or not? Okay. And students, another alternative, you can also use this second option or second equation. Okay, the second option you can is 116 divide 76 and then multiply with 1.05 times 10.5 Pascal. Okay, the second option I can show you here how to convert centimeter mercury into Pascal. Okay, you can use this equation, 116 divide 76. 76 is atmospheric pressure in centimeter mercury, and then multiply 1.01 times 10.5 Pascal. Okay, so the answer will be the same. Just a slight different because you are using different formula, but the answer will be 154,157 Pascal. Okay, so this is another option. Okay, now question C, will your answer in A and B change if the glass tube of the manometer has a larger diameter? Okay, I erase first the calculation I showed you earlier. Okay, will your answer in A and B change if the glass tube of the manometer has a larger diameter? What happens if we change this manometer with a manometer of a larger or bigger diameter? Will it shows any change in the reading of the pressure? What do you think, student? Ada beza tak kalau kita guna manometer dengan diameter yang lebih besar? Will it affect or not affect the pressure reading? So the answer is yes, it won't give any effect on the reading. No change because pressure in liquid does not depend on the diameter or the size of the container. If you remember, we learned this before in 2.1. The shape or the diameter, the size of the liquid column does not affect its diameter. The only factor that affect is the depth and density of liquid, and also gravitational acceleration from the formula. Yes. Okay. Now let us move to question 2. Kita tengok pula soalan yang kedua. Okay, this one also taken from your textbook, figure 2.2. So what do we have here? This diagram shows a mercury manometer. This is our mercury manometer used to measure the pressure in an A flow pipe. So this is the pipe. There is an A flow along it from this direction, from the left to the right. And we have a valve here. So when this valve is open, the air will flow into this part and it will push this liquid down. Okay, and students, the difference between the level of liquid in this arm is 25 centimeter. This is an open end exposed to the atmosphere. Okay, again, the first question, what is the difference between the air pressure in the pipe and the atmospheric pressure in centimeter mercury? Okay, students. So how to determine the pressure difference? Okay, this one you don't have to calculate. Just see from the diagram. This is the air pressure acting on liquid. Okay, the air pressure acting here and atmospheric pressure acting on the other. And okay, what is the difference between these two pressure? So the difference is shown by the level here, 25 centimeter. So answer is 25 centimeter mercury. The pressure difference between the air pressure and the atmospheric pressure is 25 centimeter mercury. Okay, what about B? If the atmospheric pressure is 75 centimeter mercury, what is the air pressure in the pipe in Pascal? Okay, again, this is referred to situation 2, where gas pressure is greater than atmospheric pressure. So our formula is P gas or P air pressure equal to atmospheric pressure plus H. But remember, the answer want to be in Pascal, so we find the answer in centimeter mercury first. 75 atmospheric pressure plus 25. So answer is 100 centimeter mercury. So to convert this into Pascal, use H rho G. Okay. And again, please remember when you apply H rho G, the height must be in meter. So we convert 100 centimeter into meter will be 1 meter. Okay. So the answer 133,416 Pascal. Easy. Okay. Tak susah kan? Okay, if you have any difficulties in understand any part of my discussion, you can give me a pause. You can ask me in the live chat. Kalau ada bahagian mana anda tak jelas atau tak faham, boleh hentikan Cikgu Hasnitah dengan tanyakan soalan pada live chat. Alright? Okay. So if you are okay until this point, can you give me number 2, student? Kalau anda faham, cikgu setakat ini boleh ikut saya, boleh type pula nombor 2 pada live chat. Okay. Alright, so let us take a short break before we go for some SPM practices. Since we have done with the 2 learning standard. Okay, kita dah habis 2 standard pembelajaran. Ayo kita berehat seketika. Selepas ini kita akan tengok beberapa contoh soalan berformat SPM. Okay, don't go away. I will be back after this very short commercial break. Okay, students, welcome back to my channel, Cikgu Hasnitah. I'm Cikgu Hasnitah from SMK Bagan Jaya, Butterworth, Pulau Pinang. You are now following our Physics online, free online tuition brought to you by Akademi Youtuber Malaysia, Kelab Guru Malaysia and e-didik Malaysia. Bermula percuma, selamanya percuma. Okey, tadi cikgu dah bincang 2 standard pembelajaran. Sekarang mari kita tengok contoh latihan. Okay, let us take a look a few example of question related to gas pressure. Okay, please work together with me and you can respond in the live chat as well. Okay, question number 1. So then this is example of question in paper 2, section A. Okay, you are given diagram 1.1. It shows a manometer used to measure the gas pressure in the gas tank. Okay, dalam satu tong gas. This was supposed to be gas tank. Sorry, wrong typing there. Okay, so this is the gas tank connected to this arm labeled with X and then an open end labeled with Y up there. The difference between the level of mercury in X and Y is 60 centimeter. Okay, so first, why mercury is used in manometer instead of water or any other liquid? Kenapa nak guna mercury dalam manometer? Apa kelebihan mercury? Okay, what is the advantage of using mercury as a liquid in a manometer? Can you think one reason? Actually, you can type more than one reason here. Can you give one reason, student? Boleh bagi satu sebab kenapa mercury? Apa kelebihan mercury berbanding dengan cecair yang lain? Yeah, alloy, very good. We have one answer there from alloy. Opaque. Opaque refer to the color, solid color. Opaque mean not transparent. So when the liquid is opaque, easy for us to read or to see the reading. Okay. Any other than opaque? Ada lagi tak jawapan selain daripada opaque? Okay. Wan Muhammad atau siapa juga yang berada bersama kita boleh respon selain daripada opaque. Other than opaque, what else? The advantages of mercury that make it suitable to be used as the liquid in manometer. You can talk about its density. Yeah, high density. Yeah, very good. Okay. Rashika Hilmi. Okay, Rashika. Yeah, very good. High density. That is also one of the answer. Any other else other than opaque, high density? What about the property? If you look at the meniscus of the mercury, it is opposite to the meniscus of water. Okay, so this will cause the mercury does not stick or does not wet the glass tube. So this is the reason. Okay, high density, opaque, not stick to the glass wall or does not wet the glass wall. So easy for us to read. And also it has uniform expansion when exposed to a different temperature or pressure. It expands uniformly. So it will give us an accurate reading. Okay, thank you very much for your response, everyone. Good try. Okay, next student B1. Okay, B1 very easy. You just mark X and Y with two symbols, PG for gas pressure and PATM for atmospheric pressure. Okay, which one is which? Okay, which one to write on X? Which one to write on Y? We have two options, PG for gas pressure and ATM for atmospheric pressure. Okay, how to know? Very simple. The one that connected to a gas tank supposed to be, yeah, gas pressure acting there. And the open end, atmospheric pressure acting on that end. Yeah, very good. So X is PG, we label it PG, and Y we label it PATM. Okay, now calculate, student. Calculate the gas pressure in diagram 1.1. Okay, again, observe the diagram, understand. Now we know since column X has lower compared to column Y, so we understand gas pressure is greater or higher than atmospheric pressure. So what is the equation? Yeah, gas pressure is the sum of atmospheric pressure plus H, the difference of the level of liquid in both ends. And this question, it doesn't ask you to put in what unit, so we can put in unit centimeter mercury. Okay. If the pressure asks you to put in Pascal, then you have to convert this into Pascal by using H rho G as I show you in the previous question before. Alright, so answer 136 centimeter mercury. Alright, okay, good. Okay, now we move to the next question, question C. Okay, in question C, students, you are given this diagram. Okay, It shows 3 types of sphygmomanometer. Okay, sphygmomanometer is an instrument we use to measure blood pressure. Okay, if you notice, you can find this in a clinic kesihatan, in a hospital. Okay, used by the nurse to take the blood pressure of the patient. Okay, so we have 3 types of sphygmomanometer, P, Q, and R. And if you observe clearly, what is the difference between all these 3? Okay, look for P first. Okay, the structure, this is the inflatable curve made from nylon. Okay, the curve is made from a nylon, while for Q, it is also made from nylon, the inflatable curve. For R, it is made from cotton. Okay, that is the meaning we have 2 type of material, nylon and cotton. Okay, what else different? Yeah. Teacher, we have one question here from Oleh. Okay, teacher, if question asks for gas pressure, just give the cm mercury, but if liquid pressure, use in Pascal. Okay, students, let us refer back. Okay, to respond to Oleh's question, let us refer back to the question before. Okay, if the question asks in centimeter mercury, student, in centimeter mercury, okay, for example, the gas pressure here in centimeter mercury. So in centimeter mercury, atmospheric pressure is 76 centimeter mercury, all right? And for liquid pressure in centimeter mercury is refer to the height of the liquid column. Okay, so here 60 centimeter is the height. So 60 centimeter is the pressure of the liquid in this column in centimeter mercury. 60 centimeter mercury. Okay, are you clear, Oleh? So if the question asks you in Pascal, so we convert 76 atmospheric pressure in Pascal is 1.01 times 10⁵ Pascal. And for the liquid is H rho G. Okay, so that's why we use H rho G in Pascal. Okay, am I answering your question, Oleh? Jelas tak dengan jawapan cikgu? Kalau cm mercury, unit centimeter mercury, untuk H, liquid, we took the height of the liquid column as the pressure in centimeter mercury. And for atmospheric pressure, 76. If in Pascal, atmospheric pressure is 1.05 times 1.01 times 10⁵ Pascal. And for the liquid is H rho G. Okay, so kita tambahkan dia. Boleh ya? Okay. So we go back to our discussion here. Now, the pumping bulb, student. For P, it is an inelastic pumping bulb. Okay. While for Q and R, it is elastic pumping bulb. Okay. For Q and R, it is elastic pumping bulb. Okay. So we have 2 types, elastic and inelastic pumping bulb. Okay. So now, the next question. Okay. So you have to select. For this one, you have to select or choose which type of pumping bulb and which material of inflatable curve is suitable to be used in this manometer so it can measure the blood pressure efficiently. Okay, so first, student, the pumping bulb, elastic or inelastic? What do you think? Elastic or inelastic pumping bulb? So the better choice is elastic pumping bulb. Okay, elastic pumping bulb. Why elastic? Remember we learned 1.4 before, elasticity, and elastic material can return to its original shape when the force applied is released. Or you can write easy to pump. Okay, so you can pump continuously. Since after you release the pump, it will go back to its original shape. Then you can pump again and again until you get the reading of the blood pressure of the patient. Okay, so the material now, nylon or cotton for the inflatable curve? Nylon or cotton? So our choice is nylon. Why nylon? Because nylon is strong compared to cotton. It is stronger, so it does not tear easily. Dia tak mudah koyak bila dia mengembang. Okay, it doesn't tear easily when it is expand due to the pumping action. And it can withstand high pressure. You can say it can withstand high pressure, boleh tahan tekanan tinggi, dia tak koyak, dia tak pecah, and long lasting, dia tahan. Easy to wash as well. Senang dicuci berbanding dengan material daripada kapas. Alright? Okay. So by this, which sphygmomanometer is the best choice? P, Q, O, R. So obviously, our choice is Q. Okay, pilihan yang terbaik adalah Q. Alright? Okay, good. Okay, next question. Okay, this one, example of question in section B. Section B is an essay question, 20 marks essay question. Alright? Okay. You are given diagram 1.1. It shows U-tube connected to a gas cylinder. Okay. So this is the liquid inside containing mercury. Okay. And the level between the mercury to the bottom of the column is 6 centimeter. And then students, the distance from the end here exposed to the open end to the bottom of the column is 14 cm, and this is D. D is the difference. I magnified the diagram for you first so you can see clearly. D is the difference between the level of the mercury in this column. Alright, okay, and again you can see the level of the mercury connected to the gas tank is lower compared to the level of mercury exposed to the atmosphere. So again, we understand gas pressure is higher or greater than atmospheric pressure. Alright, okay. So what is the first question? Name the measuring instrument of gas pressure shown in diagram 1.1. So what is the name of this instrument? Up here, it doesn't mention, it just say U-tube. Okay, so what is the name of this U-tube shaped container which is used to measure gas pressure? Okay, what is the answer? Aloy, Rashika, Wan Muhammad Zarif, and who else are there? You can try to respond to question 1A. What is the name of this measuring instrument which is used to measure gas pressure? Started with the letter M, ended with the letter R. Dia mula dengan huruf M, berakhir dengan huruf R. Yeah, manometer. Very good, Aloy. The answer is manometer. Without mercury is okay. Yeah, manometer. Thank you, Rashika, for your response. Okay, manometer. Okay, manometer. Then what is the value of D in a unit of centimeter mercury, student? Okay, what is the value of D in a unit of centimeter mercury? Okay, what is D? D is the pressure difference between the gas pressure and atmospheric pressure. Okay, so D is the pressure difference of gas pressure and atmospheric pressure. Okay, so in centimeter mercury, okay, what is the answer? How to find? Here we have 14. Down here we have 6. So what will be the reading here for D? Okay, how to find D? How to find D? Okay, so very easy. D is 14 minus the bottom 6. Okay, so 14 minus 6. So D will be, yeah, very good. We have a newcomer here. Zihui. Okay, I think this is my student. Okay, thank you, Zihui, for joining me. 8 centimeter mercury. Okay, very good, Zihui. Okay, answer is 8 centimeter mercury. Again, students, the difference of the height of the mercury in both arms shows to you the pressure difference in unit centimeter mercury. Okay, if you want to convert into Pascal, okay, then you have to use H rho G. Okay. Okay, now number 2. Okay, calculate the total gas pressure in unit centimeter mercury. Okay, calculate the total gas pressure in centimeter mercury. Okay, if you notice, the question is repeated again and again and again so that you can familiar and understand the solution on how to finding gas pressure in any situation you are given with. Alright, okay, so again, From diagram, you understand gas pressure is equal to atmospheric pressure plus the pressure difference. Okay, so 76 plus 8, so 84 centimeter mercury. Okay, now in Pascal. Okay, now I want you to convert 84 centimeter mercury into Pascal, just like as we did before in the previous example. Okay, convert this 84 centimeter mercury into Pascal. They give you the density 13.6 times 10 to 3 kilogram per cubic. Okay, I'm giving you a few seconds for you to convert 84 centimeter mercury into Pascal. If you're done, just share your answer in the live chat. Okay. Again, student, for those who are just being asked, I have shared you the PDF copy for this lesson. You can click on this link. Okay, later after this lesson, and I will put this link in the video description. I'm sorry that I forgot to put it earlier. So after this lesson end, I will put this link in the video description. So you can click them there from the video description under this video. Okay. Anyone done converting from centimeter mercury to Pascal? Let us see if there is any responses. Okay, no response yet. You can try convert from centimeter mercury to Pascal. This is the formula. Oh, sorry, I show you the full answer. Sorry. So this is the formula H rho G. Okay, 80 centimeter must be converted into meter. That is the first thing you do. So the formula, substitution. This is the density. This is the gravitational acceleration. So answer is 1.12 times 10⁵ Pascal. Okay, you can put your answer in standard notation or just leave it like that. 112,112,069.44 Pascal. No problem. Okay. So we have two answers. One is the gas pressure in centimeter mercury. In number two is the gas pressure in unit Pascal. Okay, very good. Okay, thank you, Si Hui. Okay, then student, they give you one situation here. What if now there is a hole on the cylinder? Sekarang ada lubang pada cylinder. If you go back to the diagram, there is a hole in the cylinder. So some of the gas will escape from the cylinder, will leak out from the hole. So what do you think will happen to the value of D? Any changes? Or will D increases? Or will D decreases, students? If some gas is escaping, so we understand that the gas pressure will be lower than 84 centimeter mercury or lower than 1.12 times 10⁵ Pascal. So when the just now this is the difference in height. So when the gas pressure is lower, so what do you think will happen to the gap? Logically, the gap will be closer. Yeah, it will be decreased. Very good, Alloy. So this is how we understand the situation. So the answer, it will decrease. If they ask you to write why, because gas pressure is decreases. Okay. If they ask you for the reason why, so when some of the gas escapes, so we understand gas pressure will be decreases. Yes, good. Okay, now this one, 4 marks essay question. Explaining the concept or explaining the working principle. Okay, imagine you are drinking from a straw. Yang puasa jangan minum siang-siang hari Okay, yang non-Muslim tak ada masalah. Okay, student, diagram 1.2 shows a kid who use straw to suck the drink in the glass. Okay, budak perempuan sedang minum air daripada gelas menggunakan penyedut minuman straw. Okay, terangkan prinsip kerja penyedut minuman tersebut. Explain the working principle of the straw. Okay, imagine you are drinking. First and foremost, what happened when you place your mouth at one end of the straw and one end is at the inside the glass containing water. Okay, what happened first? Okay, so this kind of question, sometimes you have to imagine to write the answer. Use all the WH question to write your explanation. Okay, first, this is what happened when the kid sucked the drinking through straw. Okay, so what happened? The air inside the straw will be sucked out. Okay, the air inside the straw will sucked out. Akan disedut keluar. So what happened inside the straw when some of the air has been removed? Okay, student. The air inside the straw is, you can use the word also removed out here. Okay, when the kid sucked the drink through the straw, the air inside the straw is removed out. So what happened then when some of the air inside the straw? So what happened inside the straw? We understand it will create a partial vacuum inside the straw. Okay, when some of the air inside is removed, it will leave a partial vacuum condition inside the straw. So now there will be a pressure difference. Okay, what's next? There will be a pressure difference between the pressure inside the straw and the atmospheric pressure outside. So we write the third answer. Difference in pressure occurred. Atmospheric pressure is higher than the pressure inside the straw. Okay, can you follow the sequence? Started drinking, some air is removed out from the straw, create partial vacuum inside the straw. So by this, create pressure difference outside and inside. Okay, pressure different outside and inside. So outside, greater atmospheric pressure. Inside, lower air pressure. So what happened then? From this pressure difference, it will create a resultant force acting from the higher pressure region, which is from outside. So the atmospheric pressure will push the water into the straw. So by this, the girl can drink from it. So this is how the process of drinking water using a straw from a glass. Okay, cikgu harap anda clear dengan penjelasannya and the sequence. You can imagine yourself. You started drinking, some air from the straw removed, create partial vacuum inside, and then causes pressure difference. Outside, atmospheric pressure is greater, so it will create resultant force pushing the water into the straw. Easy. Okay, solve the problem of the day. Okay, now I think we go to the last question on SPM practices before we look at the formative practice 2.3 in your textbook. Okay, this is 10 mark essay question, student. Evaluation type of essay. Anda kena pilih daripada jadual. Okay, you are given diagram point 3, it shows a vacuum cleaner. So remember when you use vacuum cleaner back home, you are applying a concept of atmospheric pressure. Okay, so you are given table 5. It shows 4 choices of vacuum cleaner A, B, C, and D with 4 characteristics. So what are those characteristics? First is the diameter of the handle rod. We have 2 options, small or big. Second, material used to make the hose. 2 option as well, aluminium or plastic. And then size of the fan, 2 choices as well, small or big. And then the power of the motor, high or low. 600 consider as low, 1500 consider as high power. Okay, remember for power, you don't write number, just write high or low. The rest you follow whatever in the table, big or small, aluminium or plastic, big or small for the size. Okay, so this is the diagram. See where is the motor, where is the fan, where is the hose and the handle rod. Okay, student, you have to choose the most suitable vacuum cleaner to use efficiently in cleaning dust at home. Okay, so you are highly recommended to form a table for this kind of question. Either 2 column or 3 column, it doesn't matter, but you have to write the characteristic for each. So the first characteristic, diameter of handle. Okay, big or small, student? The diameter of the handle. Okay, so the dust will suck into the diameter. So better to be big or better to be small? So the right choices is small. Maybe some of you think it will be big. So we choose small diameter handle so that the dusty air can move into the vacuum with high velocity. Okay, small diameter will create a high velocity air inside. All right. Okay. Now material to make the hose. Should it be aluminium or it better to be plastic? Remember, the hose must be flexible, right? It can be bent here and there. So can aluminium do that? I don't think so. So it better to be plastic material. Why? Easy to bend, flexible. All right. Okay. Size of the fan. Think logic. The fan. The fan is used to help to suck the dusty air inside into the vacuum. So better to be big or better to be small? So the answer is yes, it is big size. Why? So it will suck in more dust. It will help to suck in more dust into the vacuum. Power of the motor, student. This is also you just think of the logicity. Fikir logik saja. Kuasa dia perlu kecil ke perlu besar? Mestilah kita nak kuasa yang tinggi. High power. High power. Don't write number. Just write high power. Why high power? So that the fan can rotate at high speed. Okay, the high power of the fan enable it to rotate at high speed. Okay, so it can operate and suck in more dust. Ini boleh tulis juga another answer, suck in more dust. And the best choice is A, B, C, D. Which one? Aloy, which vacuum cleaner you are choosing? Zihui, Rashika, who else? Wan Muhammad, and the rest of you. Which vacuum cleaner is the best choice? So the answer, you choose which one. Comply all these characteristics. Comply all these aspects. So Zahan, okay, thank you Zahan for being here. Okay, answer is, Aloy also say B. What about the rest? What do you say? Yeah, so the answer is B. Very good. Okay, and for all these reasons, small diameter off-road handle made from plastic hose, big fan, and high power of motor. Okay, so done with the SPM practices. Now, as for the final exercises, let us take a look at this question. If some of you have a homework on home practices 2.3, so you can solve it with me today. Okay, save your time and save your day. Okay, student, 2.21 again. Manometer connecting to a gas tank. Okay, I think the question is just like what we discussed earlier. The same question as well. Compare gas pressure in the flask with the atmospheric pressure. Okay, compare. How do we make comparison? Compare the gas pressure. Compare mean either they are the same or different. If different, who's higher than who? Okay, who's greater than who? Okay, gas pressure higher or atmospheric pressure higher? Which one? From the diagram. Okay, from the diagram, it is clearly shown that, yes, very good. The gas pressure is higher than, the gas pressure is greater than, the gas pressure, you can use the symbol, okay, greater than the atmospheric pressure. Yes, P gas greater than P ATM, okay, gas pressure higher, okay, P gas greater than P. But here, if it doesn't label with P ATM and P gas, you must write the full terms, okay, gas pressure greater than atmospheric pressure, or vice versa. Atmospheric pressure lower than gas pressure. Okay, good. Now B. What is the difference between the pressure of the gas and the atmospheric pressure in meter water? Okay, meter water, just look. Okay, meter water. How to write in meter water, student? Okay, inside we have water, right? Okay, what is the pressure difference in meter water? Okay, so in meter water, kalau then if mercury is in centimeter mercury, now in water is meter water. Okay, so just look at the height. Okay, so the answer, just look at the height. Yeah, very good, Aloy. Okay, Anna, I think you get it now, right? Okay, so answer is, so this one centimeter in meter water, just convert cm to meter. So 0.36 meter water. Okay. If here is mercury, then it will be 36 centimeter mercury or 0.36 meter mercury. Alright, then now calculate the gas pressure in Pascal. Again, student, now in Pascal. Okay, in Pascal. Okay, this is the information you are given. Okay, in Pascal. Okay, the density of the water 1000 kilogram per cubic meter, gravitational acceleration 9.81, atmospheric pressure in meter water is 10.3 meter water. Okay, remember, we can write pressure in many units. Centimeter mercury, meter water, Pascal, in bar, Newton per meter squared as well. Alright, okay, so how to convert this meter water into Pascal? Again, the formula. Okay, first, you must find the gas pressure in meter water. Okay, so the formula is atmospheric pressure plus the pressure due to water. Okay, so this is the pressure due to water in meter water, 0.36, we calculate earlier. And atmospheric pressure in unit of meter water is 10.3. Okay, so this is the gas pressure acting in meter water, 10.66 meter water. Okay, now we convert into Pascal as we did before, H rho G. Okay, H rho G. So this one, meter, already in meter, 10.66, multiply the density of the water, 1000, multiply G, 9.81. Okay, so answer 104,574.6 Pascal. Okay, what is the difference between this question and our previous one? The difference is in the type of liquid only. So here is water, so you use the atmospheric pressure in unit of meter water. If here is mercury, so you use the atmospheric pressure in meter mercury, which is 0.76 meter mercury. Okay. Okay, done with question 1. Now we move to question 2. Yes, okay, this one the previous, the answer for the previous question. Very good, Eloy. Okay, now what are the advantages of using mercury manometer compared to a water manometer? Ini pun macam soalan yang sebelum itu juga. Mercury, what is the advantages of using mercury compared to water inside manometer? So you can write any one of this answer. Okay. Mercury manometer can measure higher pressure because it has high density liquid. Okay, high density liquid. Okay, it does not need a very long tube. Imagine if you are using water manometer, the tube has to be 10.3 meter tall to measure 1 ATM. Okay, it should be 10.3 meter tall to measure 1 ATM. But if you are using mercury manometer, you just need less than 1 meter length of tube because the 1 ATM equal to 76 centimeter mercury only. So 100 cm column is already enough. But if you are using water, you need 10.3 meter long of the tube. Can you imagine macam mana nak guna 10.3 meter panjang? Baru angkat sudah pecah sebab dia jatuh, unstable. Okay, then a rate of evaporation of mercury is lower compared to that of water since mercury is a very high density liquid, so it is having a high rate of evaporation. It does not evaporate easily at high temperature compared to water. Okay, then mercury is opaque. This is the color. Water is transparent. Mercury is opaque, so easy to read or easy to see the level of reading. And finally, you can say mercury does not stick to the glass tube compared to water. Water will wet the glass tube, so difficult for us to read the reading accurately. Okay. And then last question for today, I think, number 3. Mercury manometer is connected to a steel cylinder containing compressed pressure. Okay, they give you this situation. The pressure of the compressed gas and the atmospheric pressure are 180 kilopascal and 101 kilopascal respectively. Okay, be careful when you are giving 2 reading. Okay, the first reading refer to the first pressure. So the first reading here, 100 kilopascal, refer to the compressed gas. Okay, so 180 kilopascal is the gas pressure, followed by 101 kilopascal, refer to the atmospheric pressure. Kilo here mean 10 power of 3. Okay, 101 times 10 power of 3 pascal. This one, 180 times 10 power of 3 pascal. Okay, so here, gas pressure is greater than atmospheric pressure. Okay, calculate the difference in the height between the two mercury column in the manometer. Okay, student, calculate the difference in height between the two mercury columns in the manometer. Okay, how to do this, student? Now, calculate H. Find H, the difference in height between the two mercury column in the manometer. You are given density of mercury, gravitational acceleration here in this bracket. Okay, macam mana nak hitung? How to find difference in height between two mercury column in manometer? Okay, I give you a few seconds or a few minutes maybe for you to figure out question 3 before I show you the solution. If you get the answer, you can share in the live chat as well. Never mind. We still have a few more time before end this lesson. Okay, I can wait for you, students, as long as you can give your effort and commitment. Okay, cuba hitung dulu berapa. The most important thing, you must know what we are. Okay, yeah. Alloy, I just want to tell you, okay, if you are given this understand, you can try to draw to help you to figure out what is the purpose of the question. So sometimes drawing is always help. Okay, so you can draw, but I'm sorry, I am not good at drawing. So I hope you can understand them. So this is the gas tank. Okay, this is our gas tank. Just draw. So this is the valve. Okay, this is our manometer. Alright. Okay, I'm drawing using a mouse, so I'm sorry it is a bit messy here and there. Okay, now here you must understand. Gas pressure 180 kilopascal, atmospheric pressure 101. So the level of the mercury in the glass is in the gas should be lower. Okay, exposed to the atmosphere. So this is our mercury. Okay, kita shade dia sikit so you boleh lihat. Alright. Okay. So this is the diagram. Okay, now students, this is the level here, and this is the level up here. So this is what we are looking for, the pressure difference, H. Okay, from the question here we understand P gas at this point is 180 kilopascal. And up here, atmospheric pressure is at 101 kilopascal. So we are looking for this H. Okay, the difference in height between the two mercury column. Are you clear with the question now, Eloy? I hope this drawing, okay, help you to understand. Now you know what are you looking for, right? H. You're looking for H. What is H? Okay. Before this, they give us H, they give us atmospheric pressure for us to calculate gas pressure, right? Now they give us gas pressure, they give us atmospheric pressure for you to determine H. Okay, find H now. Yeah, very good. Thank you. Okay, welcome. Most welcome, Eloy. Okay, who can find H? If you're done, you can share your answer in the live chat. So I hope you're looking for it. Eloy, Zehan, Zehui, Wan, Rashika, and who else there? Okay, I give you 1 more minute to figure out before I share the solution. Then you can compare your answer with mine. Okay, are you done, students? Okay, let us figure out the answer together. Yeah, later you can compare yours with mine. Okay, see how to get H. So this is the difference in pressure. Okay, this is the difference in pressure between the compressed gas and atmospheric pressure. Okay, it is 79 kilopascal. 79 kilopascal equal to 79,000 pascal. Okay, this is the difference in pressure between gas pressure and atmospheric pressure. Okay, so what to do next? Okay, the difference in height of the two mercury column, our question, give you H. Okay, so who get 59.2 cm? What about the rest? What did you get? Did you get the same answer or different with Sir Hui? Okay. Then this is the formula. Okay, the pressure difference is H rho G. Pressure difference in Pascal is H rho G. Okay, 79. Okay, then H we are looking for. G is 13,600. This is the raw density of liquid and G is 9.81. So equal to 79,000, the pressure difference. Okay, so now from here, just calculate as simple mathematics, okay? Multiply and divide. So H will be 0.592 meter, or in centimeter it will be 59.2. Okay, very good. Okay, I think now you understand them, right? Okay, so what did you think about this topic? Not difficult, right? Tak susah kan tajuk ini? Yeah, thank you very much for those, and well done for those who have calculated it right. Okay, big applause for yourself. Yay! So kita telah selesaikan semua soalan. Alhamdulillah, I have finished the about plus minus 1 hour discussion with 2.3 students. So I hope you can join me again next week. Itu saja masa yang kita ada pada hari ini. Again, thank you very much for your effort. Thank you very much for your time and determination. So cikgu minta ampun dan maaf sekiranya ada yang tersilap kata sepanjang cikgu berkongsi ilmu pada hari ini, dan terima kasih kepada semua yang telah mengikuti kelas ini daripada awal sampai akhir. Jangan lupa anda boleh cetak bahan yang cikgu kongsi untuk kelas hari ini pada live chat di sana. Boleh save siap-siap link dia kalau anda nak cetak keluar. Murid saya di sekolah tak perlu cetak. I'm giving you the same module I'm using here. Okay, murid yang lain daripada sekolah lain bolehlah cetak dia sebagai bahan tambahan. Okay, terima kasih cikgu, sama-sama. Terima kasih kembali. 1,000 thanks, million thanks to all of you. Okay, semoga kita berjumpa lagi dalam masa yang akan datang. Don't forget to join me again next week. We will discuss the next content standard 2.4 Pascal principle. Okay, 2.4 Pascal principle. Same day, Sunday, 11 a.m. Okay, till then, Assalamualaikum and goodbye everyone. Have a pleasant Sunday. Okay, thank you. Bye-bye.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang bervisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.akademiyoutuber.com. Berusaha ayu capai kecemerlangan, berpadu ayu cipta kegemilangan, bersatu ayu bina wadah terbilang, terus berjaya bersama ayu.
Berusaha ayu capai kecemerlangan, berpadu ayu cipta kegemilangan, bersatu ayu bina wadah terbilang, terus berjaya bersama ayu.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bervisi guru ayu, mencapai misi yang satu, bervisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.